Hello, this is Mr. McMurray. Hope you're having a good Thursday morning. Mine's been a little bit rough, I guess, because besides it being about five something in the morning, I just taped this and it all disappeared. Okay, so we're gonna do this. Hopefully, it will go a little bit quicker this time. All right, or go a little bit better. All right, let's try this. So this is for this test that you'll be taking this afternoon. There will be some elastic and inelastic collisions problems, and there will be a lot of them that use the or some that use the impulse and change in momentum. The fact that they're equal to each other, impulse is equal to change in momentum, and then therefore force times time, which is the impulse, is equal to mass times change in velocity, which is the change in momentum. All right, but let's talk about elastic and inelastic first. All right, if I give you a picture like this, then you've already got it. All you got to do is say the momentum of this one, which is kilograms times the velocity, plus the momentum of this one, which is kilograms times velocity, is going to be equal to the momentum of the two of them added together afterward, because momentum is always conserved. And so you're going to have the total number. So we can say whatever's on this side, if you add them together, is going to be equal to whatever's on this side. All right. Now, one thing you have to watch out for, you do not have any on this problem. All of these are going to the right, which means there are positive numbers. But on some of these questions later on this worksheet and on the test, they may have some going the opposite direction. Remember, anytime it's going the opposite direction to the left, it is going to be a negative velocity. All right, not a negative mass. Okay, you can't have a negative mass, but you can have a negative velocity. All right, so to set this formula up, you would take the mass times the velocity of the yellow ball plus the mass times velocity, 4 kilograms times 4 meters per second of the blue ball, all right, and add those two together to get this side of the equation, all right. And then on the other side, you would have the mass, 6 kilograms, times the final velocity of the yellow ball, which is our variable. We don't know that, okay? And on this side, you're going to have the mass times the velocity over here for the blue ball on this side, which is going to be 4 times 10. All right, now, since we've already done that part, we can do this a little quicker. This is going to give you 60 plus 16, okay, if you work those two out. And if we add those together, I'm going to change it back to 76 because that's what it would be. Kilograms times meters per second. Whoops, per second. All right, okay, is equal to 6 kilograms. I'm just going to write this way this time, times the final velocity. All right, plus 40. Okay, so we need to get the 6 kilograms times final velocity by itself, because we need to get the variable by itself. So we would subtract 40 from this side, which would get rid of that. Boom, gone. All right, and we would subtract 40 from this side, which is going to give you 36. Okay, then you divide both sides by 6 kilograms, and that would give you your final velocity. And the kilogram here would cancel the kilogram there, so your final units would be meters per second. And so I'll let you divide 36 by 6 if you can't do it in your head, use your calculator, but there you go, and that would be your final answer. Okay, now this one would be similar, you're going to use it, but this one was an elastic collision. They bounce apart, and that's why we had two separate velocities here at the end. All right, on this one, they stick together, so you will use the inelastic. This side, same thing, mass times velocity plus mass times velocity. But on the other side, since they're going the same speed, we can add their masses together and multiply it times VF. And it's actually a little shorter than doing it this other way. All right. Now, number 19 down here is an example of using impulse. Okay. In this case, you have a 0.53 kilogram basketball, which hits a wall head on with a speed of 18 meters per second, and it bounces off or rebounds with a speed of 13.5 meters per second. It touches the wall for 0.100 seconds, or a tenth of a second. First of all, let's know the impulse. Well, if we look at the formula, impulse is force times time. We don't know that. Okay, we know the kilograms, which would be mass. We know, let me just put that there. All right, So this would be our mass. So we know our mass, okay? We know how fast it was going into the walls, which would be our velocity, but that's going to be our initial velocity. And we know this number, it bounces off at a speed of 13.5. That's going to be the final velocity. And just for the record, since it's bouncing off and rebounding, it's going in the opposite direction. So that is going to make that a negative 13.5 meters per second because it's going in the opposite direction. If it hits and bounces off, it's going in the opposite direction. So it's going to be a negative 13.5 meters per second. All right. So here's the deal. We don't have newtons, which we would need to find the impulse. But we know that impulse, force times time, is equal to the mass times change in velocity. Okay? And turns out that our mass is 0.530, we know that, times the change in velocity. Well, change in velocity is the final velocity minus the initial velocity. Well, our final velocity is negative 13.5 meters per second minus the initial velocity, which is 18. All right, and that gives us 0.530 times, and I believe if I do this in my head correctly, that's going to be negative 31.5. Okay, and that will equal whatever it's equal to, and that will give you your impulse. All right. Now, I want to say it's around, I don't know, I'll just say. All right. Now, once you have your answer there, you can plug that answer in here for the impulse. Okay, where J is there, sorry. Put that answer there. Impulse is equal to force, which we don't know. It wants to tell us the force of how hard it hits the wall, times the time, which is 0.1 seconds, 1/10 of a second. And if we divide both sides by the number of seconds, that will give us the amount of force. Okay, so that's how you would do that one. All right, and those are fairly easier. Now, the last thing I want to do is one more elastic inelastic equation. Okay, so you're at an amusement park. You have two brothers, Tubby and Chubby, who are in separate 36-kilogram bumper cars. All right. Tubby gets his car cruising at 3.6 meters per second and collides head-on with Chubby, who is moving in the opposite direction at 1.6 meters per second. After the collision, we know that Tubby and his car bounce back at 0.5 meters per second. We need to figure out how fast is Chubby going after the collision is over. Okay, and which direction will he be going? Will he bounce back this direction or will he go this direction? Well, we'll have to wait and see. All right, so Tubby's going this direction, so his velocity is going to be positive. Chubby's going the opposite direction, so we'll make his negative. After they hit, Tubby's bounces the opposite direction, so now his is going to be a negative velocity, and we don't know about Chubby's yet. We'll have to find it out. All right, so if we plug into our formula, as they bounce apart, it says that Tubby bounces off, so that means this would have to be an elastic collision. So basically we take the mass of Tubby's car, all right, which would be Tubby plus the car, so that's 50 plus 36, that gives you 86 kilograms, okay, times his speed, which is 3.6 meters per second, plus the momentum of Chubby's car, which is Chubby, 62 plus 36, which gives you 98 kilograms, times his velocity, 1.6 meters per second, but it's going in the opposite direction, so it's a negative 1.6 meters per second. All right, that's going to be equal to Tubby's velocity, 86 kilograms, times his speed or velocity, 0.5 meters per second, but he's going backwards, so it's going to be negative this time, plus 98 kilograms times his final velocity. All right, now, once you have that set up, you're just going to solve that. You would multiply these two, boom, get that answer, multiply these two, put that answer. Then you will either add, or if this one's going to be negative, so you actually kind of subtract them, get that answer. You're going to multiply this and get that answer. It's going to be a negative number. So you're going to have to add that number to this side and this side to get rid of it. And then you will divide both sides by 98 kilograms to find out what the final velocity is. And that will be your answer. Now, if that number is negative, that tells us that Chubby is going this way, to the left. All right, if that number is positive, that would mean Chubby bounces back the opposite direction and goes in the positive direction. All right. So there you go. All right. Hopefully that helped you, and enjoy. Have a good time. Hope you're ready to take the test with the problems this afternoon. All right. Have a great day, and I'll talk to you next time.